What is up, team? It's your boy, the Canologist. We're going to be doing another Leetcode and OSRS AFK training session. But this time, we got Dragon Defender. So I'm going to show you guys the stat bonus on this bad boy, because you guys have no idea, like, the difference in stats with the Dragon Defender. Like, I just want to show you guys, it's night and day, like, what you can do with a Dragon Defender. And if you didn't watch my guides, I'll show you guys how to get Dragon Defender in my guide list. So check that out. Here's the current stats without Dragon Defender. So 97 slash, stab, and I'm using this, 2.4 damage. So the reason why I opted for this versus the Obsidian is because you get more attack speed, which then equals more points. And then I can then imbue my helmets and stuff like that once I get a Slayer helm or something later on in the game. Now I'm going to add, so look at this, and then look at these strength bonus and all this stuff here. Boom. Takes it from literally 97 to 122. It's literally crazy. And then strength bonus 107 up until 113, so it's plus 6 strength bonus. So that's a crazy amount of stats in attack, and I'm going to be way more accurate at a slight cost of some defense. So it's like, this is peak setup right here. Well, I could get prims, but I need 75 defense. And I could get a torture, but that's gonna cost me an extra 7 to 10 mil for that. So like, for now, let's just stick with this gear and see how it goes. So same thing, go to these guys. Got a bunch of overloads. Let's go up to 600, that should be okay. Actually, I'll do 800 for the first one. Turn your auto retaliate on. And then we will get to the leak codes very shortly. I got my pommel focus ready. Whoever's in proximity, I got special attack on. Boom. Let's go use that. Okay, and then we'll start this timer. And then basically now we'll start this question. It's called gas station. So we're not talking about 7-Eleven. We're talking about this Leetcode question right here. All right. So this Leetcode question, gas station. Let's make it slightly larger so I can see the code. Okay, so then can complete circuit. We have basically, based on the typing, we have gas is a list of integers. And cost is also a list of integers. And then it has an integer output. Okay. What does that mean for us, though? Okay, let's see. There are n gas stations along a circular route. Amount of gas. You have an unlimited gas tank, and it costs I. Cost I of gas travel from the ith station to I plus 1 ith. Okay. I plus 1th. You begin the journey with an empty tank at one of the gas stations. Okay. Given two integer arrays and a cost, return the starting gas station's index if you can travel around the circuit once in a clockwise direction. What the fuck is this? Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. So as long as there won't be multiple solutions. For the way this sounds, I'm leaning towards thinking this is a graph question. So like, that's just One of many. Okay, I gotta really think this one through. I have no idea how to do these graph questions yet. I didn't really study that far, but we'll figure it out on the fly. Worst case, we'll just chat GPT it. A circular route. You have a car with an unlimited gas tank, okay, and it costs I of gas to travel from the ith station to its next. Okay, so I guess let's just draw a station. Like the way this looks like, it looks like a graph, honestly. It looks like a graph with some sort of, so let's just say this is the start. And then there's a bunch of different stations. Right, so let's do that. Start, and then this points to this node. So let's say this is I. This would be I plus 1. And then you could kind of go by that. So that would be here, this would be here, this would be here. This would be here, and then this would be here. So this is some sort of graph type structure because you have direction and then you have nodes that you want to iterate. And I guess like, so now we know it's circular. Ith station, you begin your journey with an empty tank at one of the gas stations. And it cost I of gas to travel. So I'm guessing there's a gas list and a cost I of that gas list. I did 2 scoops of protein. It tastes like fucking ass. Peanut butter. I thought I got the regular chocolate one. I don't like additional flavors and sweetness. Like, I'm one of those guys that'll drink black coffee with double shots of espresso. So it's bitter. It's fucking bitter, bro. Because, like, too sweet is like, I don't know, maybe it's an age thing. I'm 29. Maybe it's an age thing. I just don't like sweetness like that anymore. There used to be a time where I just like pound chocolates from Halloween. I just fucking down like 30 chocolates. But I don't do that shit anymore. Ugh. Fucking disgusting. Okay. Let's get back to it. So we went through this. We know it's some sort of possibly a graph. Or this could just be a linked list. Technically, this is a linked list if we go by the structure of it. It's just a linked list that connects back to itself. And a graph is just basically a linked list. It follows the concept of a linked list. It's based upon that structure. So, I guess it could be. Okay. Now let's dig a little deeper into this. There are N gas stations where the amount of gas at the ith station is gas I. Okay, so there's gas at each station. And it costs I to travel from... Oh, okay. So each of these stations has an associated gas. So let's call it G. This has a gas. This has a gas. This has a gas. This has a gas. And then this cost is what it takes to get from A to B. So this has a C. This has a C. 3, 4, 5. So each node has gas. That's where we start with 0. And then we acquire gas, or we lose gas from that starting point, going from A to B. So this is the part where it gets fucking weird. This is the part that I don't like about this question, and I'll show it to you right here. Did I just get a strength level? 81 strength. Nice. Nice. That's my motto right there. 81 strength. See, the thing I don't like about this question, it says you have a car with unlimited gas tank. But technically, your gas starts at 0. You begin the journey with an empty tank. So I guess this unlimited gas tank, don't be fooled by this. This unlimited gas tank basically means you can, if you go to different nodes, and let's say like node A has 0, right? Or node A has 5, you travel 3, you lose 2. So now you have 1 unit of gas, and then node 2 has like 10,000. This has an unlimited gas tank, so you'd be at 10,001 units of gas. So don't confuse this with the second part. This is the actual important part. You begin the journey with an empty tank of gas. Okay, so we start at 0, and we fill at said node. Because it says here, their end gas station is where the amount of gas at the ith station is gas I. So you just get wherever you're at, and you add that to your total gas tank or whatever the fuck. That's what I think the solution is trying to push us towards. But there's a lot to unpack there, so let's get started with some code. So now we have like a basic understanding. Given 2 integer arrays, return the starting gas station index if you can travel around the circuit once in a clockwise direction. Otherwise, return -1. If there exists a solution, it is guaranteed to be unique. Okay, so you will only have one solution. My favorite thing to do with these types of questions is just try to get an easy win out of it. I could probably finish partials of the test case. It shows you're at least reading the requirements too. So let's go through that. Run it. See, I already passed one test case because it's just not possible to do it. Okay, so now let's get into the actual examples. So 1, 2, 3, 4, 5 cost 1 to 2. That costs 1, 2. What does the cost do though? Input gas cost was 3, so technically start at station 3, fill up with 4 units of gas. Your tank is now 0 plus 4. Oh, so you don't fill up at the unit you're at. So you start at station 3, then you go to 4, so you get 4. And then 4 minus 1 plus 5. gives you 8. Then you travel back to station 0, which costs this 8 minus 2. Plus 1. Plus 1. So where you're going you can add, and then where you're coming from you can not add. This is a strange question indeed. Okay, let's look at this. N equals gas dot length equals cost dot length. So the constraints N. So it's never going to be uneven. There's just a gas and a cost associated for each thing. And then N is between 1 and 10 to the 5. So we could have N spots. And then gas, less than 0, cost. Gas at I is less than or equal to 0. No, gas I is greater than or equal to 0 because it's on this side. The input is generated such that the answer is unique. Okay, so there could only be one answer, if there is an answer. Does it give us the starting point? It doesn't even tell us. So how do we do this? How do we even go about doing this? I have no idea. I guess first I would want to know what each gas station has. Just based on this example, let's take a look. Try to reverse engineer this. This is an example of what we want. I don't know. There's just a lot to take in. So we have the diagram here. We have a bunch of shit here that we could take a look at. We've already kind of established what we're looking for. We could say total gas equals 0, or gas available equals 0. Travel to station 4. Oh, and then the cost of that. Well, technically, if you start at 3, you start at index 3, 0, 1, 2, 3, so that's 4. Oh, start at station 3? Start at station 3? What is that? Index 3, 0, 1, 2, 3, that's 4. Oh no, so you do start at where you're at. Then going to the next one is 4 minus 1 plus 5. That's the cost of going to the next gas station. I mean, I would want to find the largest index and then maybe start from there, because then if I start at the largest index, I have the most amount of gas, and then based on that, I would have the bandwidth to go around. So return the starting index, travel to station 3. Okay, wait, what is the constraint though? Technically, you could have multiple solutions, but this solution allows you to get away with it. I'm thinking. What do I want to do? How I would approach this is I would just look for the cost of each thing and this. So I could just map it, put it in a hash table, combine the tables. I'm also trying not to fall asleep because the lights are dimmer than usual. So it's like, it's a two-pronged issue I'm facing. Should I get a Red Bull? And actually, I should get a Red Bull. I'm going to do that right now because I want to finish this Leetcode. I'm just trying to struggle with it because we got to suck to be good, right? So let's just suck together. I don't mind looking like a fool. If we're gonna get better as developers. So now let's take a look at what's going on. Okay. So back to this diagram again. We now have an idea of what's going on at each thing. So I'm just gonna get rid of this. Okay, so now let's get back to this diagram. So now we know each one has a cost associated with going to the next one and then a value. So now we have to find the ratio, I guess, of each one. I mean, let's not overcomplicate it then. In that case, I would want to start where there's the highest amount of gas and the lowest amount of cost. That's my thing. So I guess by going there, I could compare highest amount of gas and lowest amount of cost and map the two. So I could just map the cost and then just take the difference. And then whichever one has the actually that leads to the other question. There's the index, there's the cost, and then there's the index, the cost, and the gas. The trifecta. I'm thinking, but I think that is the way to go for this. We have to use some sort of hash table maybe. So let's do that. Let's go 4. And then let's just map a 1-to-1. Gas at I, and then cost associated with I. Because it would be, why would you start at number 3, index number 3, and not index number 4, where the 5 is? It's because you have a cost of 2. 5 minus 2 is 3. Right, whereas this has a cost of 1. And there's only going to be one solution. Okay, so I can go for I in range. Let's go length of gas. Are these going to be equal? Yeah, gas equals cost. So that's the clue. So that means we know we could just map it directly. That's another kind of giveaway, I guess. And then let's create a dictionary called stores. And let's go here. Let's go to empty dictionary. You just do this. Okay, so that's the correct syntax. And then we can go for be in range because I want to get the values. And then index of the dictionary maps to the same index. Travel from I to its next destination. It costs I of gas to go to the next. So let's start by creating a map. So for I in range gas, so then basically what I'm doing is I'm taking these two values, the gas and the cost, and then I'm just saying these two arrays G, C, and then I'm just taking my dictionary, and then I'm going to do this, G, C, G, C. What did I get? Oh, hit points, nice. G, C, into perpetuity, as long as it takes. So that's pretty much it for the strategy, and then I can take the difference between these values. And whichever one has the greatest difference is the one I'll go with. Because essentially that would mean essentially that would mean that's the best option. So back to Leetcode. Let's chase this solution by so basically stores I equals or I could do an array. I could do gas minus cost. Your tank is 4 minus 1 plus 5. Okay, let's do this. 4 minus 5 equals 8. There's nothing higher than 8 on here, so we're going to do 4 minus 1 plus 5, 4 minus 1 plus 5, 4 minus the cost plus the cost of the next. So stores I, this is going to be the index that we're going to return. And whichever index maps to the highest value is what we're going to return. So basically it's going to be 4 minus 1 equals 5. So let's mimic this. This is going to be the current index of gas. So gas at I plus gas at I plus 1, because that's what this does, minus the cost. This is going to be the standard. And then when we get to the last element, we have to go here. So if length of the gas minus 1, we do this. You get the stores I, you get this value. We're creating the edge case basically based on the instructions. So you get gas at I, the final value, then it loops back to 0. So gas at 0. And then minus the cost at I, we get that value. And it goes into stores for that index. And then what we'll do is so then we'll break out of the loop at this point, because that basically tells us that we're at the end of the loop. We don't want to create an infinite loop. Well, technically it's a for loop, so it's not going to go past the length of I, because I is just going to keep increasing. But the break here tells it that we don't want it to go here. And it's already in the last element. So the next step is we want to find the greatest value between this, the next, and the current gas that we have to pay for. So then we go find the key with the maximum value. Okay, so there's a built-in thing here, so we can go max key. And this key is the index that we want to return if it's not -1. So we're going to do if get the max key. So max my dictionary, so they gets the dictionary, it probably loops through. Max is an iterable function, so it goes through whatever your list is. So in this case it's a dictionary that's an iterable, a list is an iterable. So it says in my dictionary, the iterable is the key, and then my dict.get. Dict is dictionary. Pause. So yeah, we'll do that. I'm going to use this function. So max key equals max, because this is an iterable. I mean, let's look into the docs, because I just want to show you guys Python max. Returns the item with the highest value, or the highest value in an iterable. So max could be n. Max a, and it should return 9. Yeah, there it returns 9. So you can give it a list too of items. Yeah, so we're just gonna do max and get the max key. Oh shit, I forgot to hit this. Anyways, what do I want to do? Yeah, should be max. Stores is my iterable key. And then what do they put here? Key equals my dictionary.get. So basically I want to get my value. So get the keys for each. Oh, my dict.get based on the key. So it's going through each dictionary item, getting the key.get, which is the value. Get the value. Key with the maximum value is max key. That's what I think, at least. So key equals And then what do they do here? Do they go yeah, my dictionary.get. Okay, cool. So then it goes stores.get. And no semicolon. Yeah, so that's it. I guess if stores a key is less than or equal to 0, that means you can't make the trip to the next part. And then there we could return, we can return -1, otherwise we just return the max key, which is the index. Return max underscore key. I think this should be good. This does what I kind of wanted to do. Let's look at the requirements again. Let's just try running it first. I'm just curious. Stores key less than 0. I'm on the right track because you have to use max to get the value that's highest. And I assume that's where he starts because he picks the highest number. So that's 8. So here I would get the max key based on the I values, and then make that, and then what? Then what? Then what? Then what? Then what? If stores at key is less than or equal to 0, then what? I would return the key. It's less than 0. How do I know that though? Stores at key. How does it know that specific key? It's no longer in the loop. So I could do a check here. There should technically be no zeros. Unless you're starting out. Stores key -1. So if it's less than 0, return this. Otherwise, go here and then return the max key. But how does it know what key? This is very tricky business. The max key equals thing. So how do I know what key? How do I know what key? How do I know what key? What's the marker that would tell me? Oh, I could just go min key. Max key. Return the index with the highest value. We get the max. Index with the lowest value, and then we just go dictionary add index. So we can go we just like Uno reverse what we did with the other one. So then we go keys equals stores.get the min now, and then basically if stores at min key return -1. This should work, I think. Unknown error. Let's try reloading the page. Oh, it deleted everything. Good thing I copied it. Okay, he wants indentation to be different. Indentation looks fine to me. It's just that they do it in a weird way where you don't think it's correct. But let's try that. Why isn't this working? You need to log in, sign up to run or submit. Okay, let's log in. So stupid. I don't know. Let's feed it to ChatGPT and see what's going on. Apparently it's throwing an error. So there's some sort of condition I'm missing. I'm hitting a decent amount here. Okay, the only thing now is, yeah, let's check it on ChatGPT. Let's figure out where. How good was my attempt? Interesting. Let's the cumulative balance as you travel a circle, not just. The problem depends on the cumulative gas, not just the thing. Your stores is at best 2 station snapshots. Ignores all the costs. I'm not gonna lie, I'm actually fucking sleepy. Let's continue this tomorrow. Actually, no. Let's persevere. I'm not gonna go to sleep until this is done. Even though I'm fucking exhausted. I had like 2 hours of sleep yesterday, so. We're gonna get through this one. Some gas is less than some cost. Counterexample. Oh yeah, technically, if you have less gas than the cost, then yeah, you would have a -1 there. Let's try this. I'm just curious. Oh shit. So pretty much it all worked. It's just the condition for checking the false. Because this already checks for the true. Let's try this. Okay. So it makes it through a bunch of these. It doesn't do it for all of them, but it does it for some of them. So output is 0, expected 3. Why does the output become 0? Why does it become thing? Okay, so 5828 gas, 63. Min stores, key stores dot get. So I get the minimum. Well, I don't need the minimum anymore. I have the maximum, which is doing what I want it to do. I don't know. I don't know what could be causing it to deteriorate. Where's the function break? Let's narrow it down actually. Because it's late. It's 12:24 a.m. I gotta see past my own deficiencies. Subtle issue with these breaks. It's the last. Start 0, tank 0. Meanwhile, yeah, because I also did this. I did this. Start end. Mixes two gas values but only one cost. This does not represent net fuel after leaving gas I plus gas I plus 1. You compute for last. Gas last plus gas 0. I'm like also fighting sleep deprivation. Okay, so stores metric is meaningless for the problem. You compute mixes two gas values but only one cost. That does not represent net fuel. Okay, cool. What is the way it represents? You will pick max key. You still pick max key for the bad metric. Even though you now correctly check for thin global feasibility, the chosen max key can be a stage for which you can't even leave. For the last index, then double joint, so double count station O's gas in a unrelated way to any travel step. Whoa. Some gas, start 0. Tank of the gas, tank. Okay, so it does a cumulative total of the tank. Start. I plus 1. So now it iterates to the next one for I and thing. I plus 1 if tank is less than 0. Return start. So this I get. Some gas, then we get start 0 for iron range line gas. Okay, cool. We just do the same thing. It's pretty identical to what I have, iron range line gas. Then where does it differentiate? Tank, which is starting from 0, equals gas at I minus cost at I. Okay, if the tank is less than 0, start equals I plus 1. Okay. What about when you get to the end and then you have to start at the beginning again? But that makes sense. If it's less than 0, the tank, then you can't start there. So the start now becomes I plus 1. And the tank starts again at 0. This is actually a very intelligent solution. You can literally put this in here. I'll put this at the top. So now that's there. And then mini key. I don't need this anymore. I don't need this anymore. Then I just attack it and return it up top. I could get behind that. You just start again for the next iteration. So he actually made it even simpler than what I thought. I thought you had to do some difference between each one. But he's just doing cost minus the gas at that specific index. So let's try it and see what's going on. Worst case, we debug it. Oh yeah, return max key. I'm supposed to return the start value, which gets updated. Because keep in mind, I increments, but start does not increment until we meet a condition that goes beneath 0. So when it does go beneath 0, we know to push start to the next one. What does that mean for tank? Yeah, tank equals 0. Start equals 0. Yeah, let's run that. That should work. So it was way simpler than I thought. I thought you had to actually map it and then do some stuff and use a graph, but you just end up looping through the elements of 2 arrays. That's wild. This is where over analytics can actually be to your detriment. Don't overanalyze the question. Wow. He literally just did the exact same thing we did. So like just the cost is less, so that way you never have gas less than the distance, the cost. The second thing is he has a start value here which starts at 0, the first index. It only increments when the tank goes under 0. Otherwise you're just doing it on a global gas tank, which basically we know is going to work, because otherwise if it didn't work it would do this. And there's only one unique solution. So wherever you don't have to apply this, start finally ends there, and then they just add. You have to go add +1, because start +1 to go to the next station from where it's already currently at. The I is the index of where it's at. So yeah, that's pretty much it. I overcomplicated this, so my mistake was I thought you had to actually make a graph, and because I saw the instructions, I was kind of overwhelmed by it. Basically, all you did was take the 2 arrays, iterate over them, and then get the total values to make sure that you have enough gas for the round trip. If you have enough gas for the round trip, you know you can now run your next loop, which is right here, and then you just pinpoint the specific area where the tank goes less than 0. Tank goes less than 0, you know to shift. So yeah, if you like this guy, please give it a thumbs up, subscribe, comment below. Kinologist out. Happy coding.